Okay, let's take a look at it. It's number 83. And I'm looking at the first integration with respect to x over here. And one thing I noticed about that integrand 1 over 1 plus x to the fourth, it looks like it's going to be a tough integration if I do it with respect to x. So I'm going to see if I can change the limits around a little bit. All right? Instead of doing x first, I'll do y first. Might make it easier for me. So the first thing I do is talk about the lower limit for x, and that would be y equals, let's take a look at that. I'm sorry, x equals y. That's right here. The upper limit is going to be x equals 1. I'm going to draw a picture of that. We'll look at a better picture later, by the way. X equal y's look like this. X equal 1, whoops, sorry about that. X equal 1 looks like this. All right? Maybe we should write that down. X equals y, x equals 1. All right? Let's do the y now. So y equals 0, and then y equals 1. Well, pretty simple. I mean, what region are we getting? Y equals 0, a line like this. Y equal 1 look like this over here. So this is the region over here. That's relatively simple. So what I'm going to do is I'm going to try to switch the limits around. Right? So it's a very simple region to do it. So does it make it easier? I think so. So let's erase this over here. And I'm going to try to switch it around. All right, so I don't know the limit yet. We'll put that down in a moment. So 1 over 1 plus x to the fourth. Instead of dx, we're going to go dy. And then it'll be dx. Right, so I got the rectangle. Let's reminisce what we did before. And so the y's are going from 0 up to that line, which is y equals x. Let's back away. Let's do the x's. The x's are starting at 0, and they're stopping at 1. All right, so I just changed the order of integration. And let's see if we can do it. And I guess it looks doable. Let's put this down. And I want to do this part first. Let's see what happens. What do you get there? You get y, 1 plus x4. Again, I'm treating x like it's a constant, and it goes 0 to x. What does this give you? This gives you x over 1 plus x4. Now, granted, this might have become worse. I don't know. Take a look at it. What do you get? 0 to 1. Then you get x, and you get 1 plus. Now, since I want to see that derivative, I want to see a function whose derivatives in the problem, and I really want x dx somewhere. So what I'm going to do is I'll call this thing x squared. Right? I want to integrate this thing if I can. So what do you do? I'm going to say u equals x squared. Du is 2x dx. Well, when x is 0, u would be 0. When x is 1, u would be 1. X dx is 1/2 of a du. And on the bottom, what do you get? You get 1 plus u squared. Do I recognize that? I do. 1/2 arctan of u. Limits of integration go from 0 to 1. 1/2 arctan of 1 minus the arctan of 0. Mixing notation there. Arctan of 1 is pi over 4. And the arctan, I'm sorry, I forgot to put a half here. The arctan of 0 is just 0, so I'm not going to write that down. What does that equal? Pi over 8. Let's look at the key, see how we're doing. And I do see that, and I do see the work down over here. But I also see Sage Code. They're certainly going to provide a better picture for you. And again, what do I mean by better picture? Machine is drawing it. My chicken scratch doesn't look that great. Even my penmanship looks awful, which again, is another advertisement. Learn to type things up, by the way. Thank you.